This video is in class 48. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle, which there are three sides, must be greater than the length of the third side. Meaning, you should test using groups of 2 greater than the third side. But if you test the sum of the two smallest sides and they satisfy this theorem, if the two smallest numbers add up to be bigger than the third side, then every other set tested will work as well. So to start, what I'm going to do is I'm going to identify three sides. So small, medium, large. So 5 plus 8 must be greater than 11, which means 13 is greater than 11. That's true. That was the two smallest sides. So meaning if I take 8 plus 11, is that greater than 5? Is 19 greater than 5? True. And then is 11 plus 5 greater than 8? 16 is greater than 8. That's true. So if I test the smallest two sides, the small and the medium, and that's true, all the other sums will always be bigger. So this is a triangle. Okay? So the next two, the two smallest sides, so this is small, medium, large, is 4 plus 8 bigger than 12. Is 12 bigger than 12? No. So since that's not true, this is no, not a triangle. Or just not a triangle. Okay? Ooh, this one looks complicated. We got a radical. So I don't know what this value is. So on my calculator, what I'm going to do is I'm just going to take 10 times the square root of 2. And that's a decimal. So this is approximately 14.14. Now what that does is it allows me to see that I have a 10, a 14.4, and a 12, which means this is my small, this is my medium, this is my large. So what I'm going to do is I'm going to test is 10 plus 12 greater than 10 root 2. Well, is 22 bigger than roughly 14.14? That answer is true. So yes, I have a triangle. Okay, next one. 16, root 26, and 23 are my three sides. I don't know what the square root of 26 is, so I'm going to take my calculator. And second square root 26, I get 5.09. So this is 5.09. So the question is small, medium, large. Is the square root of 26 plus 16 bigger than 23? Well, that's 5.19, so approximately is 21.09 greater than 23? The answer is no. So this is not a triangle. Okay. Ooh, this one's even more complicated, more radicals. So I don't know any of these. So second square root 13 is approximately 3.61. 2 square root 5 is approximately 4.47. And 4 square root of 2 is roughly 5.66. So small, medium, large is the square root of 13 plus 2 root 5 bigger than 4 root 2? Well, that means is approximately 3.61 plus 4.47 greater than 5.66. The answer is yes. And so, yes, I have a triangle. Okay. So now, sides of 3, we've got 3, 6, and 9. So 3 plus 6, because small, medium, large. Is that greater than 9? Is 9 greater than 9? No, not a triangle. So this is the level 4 part of your standard, you're going to turn the page, and then we're going to get to the 2 questions that we have not covered yet. So at the top, you have the Pythagorean theorem converse. And what we do is we compare the c squared, or the hypotenuse squared, to the sum of the legs squared, which is the a squared plus b squared. If they are equal to each other, then the triangle is right. If the sum of the 2 legs is greater than the hypotenuse squared, you have a acute triangle. And if the hypotenuse squared is greater than the sum of the 2 legs, then the triangle is obtuse. But before you can do anything, you got to determine if it's a triangle first. Then you get to do this, okay? What you want to be very careful of is that you always identify C as the largest side, because the largest side of these shapes, or sorry, not the shape, this triangle is going to be the hypotenuse if it is a right triangle. So with that, determine whether each set of sides forms a triangle. If it does, then classify the triangle form. So in the upper right-hand corner, or near the numbers, what I do is I always take small, medium, large, and I do really quick 9 plus 10, is that greater than 15? If that is true, so 19 is greater than 15, I say yes, it's a triangle, okay? Then I can perform this. If it's not a triangle, I can't classify it. So with that, my largest size is 15, so I'm going to go 15 quantity squared. My question is, what is that compared to my other sides? So I have 9 squared and 10 squared. So I'm going to add these together, okay? So 15 squared on the calculator is 15 times 15, which is 225. So this is 225. And then this is going to be 81, and this is 100, which means when I add these together, this is 181. Who's bigger, or are they equal? So the c squared, or the individual squared, is bigger, so since that is bigger, that means my largest side is opposite an obtuse angle, so I have an obtuse triangle. So on the next one, small, medium, large. So before I do that, I'm going to take my 2 smallest sides, so small, medium, large. I'm going to take 8 plus 15, and I'm going to check to see if that's bigger than 17. That's true, so I have a triangle. That's the level 4 part. But before you can do this, you got to test to see if it's true. Okay? So, longest side, or biggest side, is 17, so I'm going to go, oops, wrong color. 17 squared. What is that?
Your attention, please. Christopher Shire, if you're in the building, could you please go to door 13? Christopher Shire, if you're in the building, please go to door 13. Thank you.
So 17, and then I have 8 squared, and I have 15 squared. So 17 squared is like 343, I think. No, 289. 289. This is 81. And this is 225. This is not 81, that's 64. So with that, 64 plus 225 is 289. Since these are equal, I have a right triangle. So on the next one, once again, small, medium, large is 4 plus 4 greater than 5. That's true, so I have a triangle. So I'm going to take 5 squared and get 25. And then I'm going to compare 4 squared and 4 squared. And we're going to see if these are bigger or smaller. So that becomes 16 plus 16, which is 32. 32 is greater, so then this is acute. Okay, so that's with integers. Now with numerical values, I need to see what the square root of 14 is, decimal-wise. This is 3.74, so small, medium, large. So 3 plus the square root of 14, is that greater than 5? That's true, so I have a triangle. So then we're going to go 5 is the largest side. So 5 quantity squared. What does that compare to the other two? So 3 squared, which is 9. And then square root of 14 quantity squared, which gives you 14. Add those together and you get 23 compared to 25. 25 is bigger, so this is an obtuse triangle. The square root of 41 is approximately 6.4. So 3 plus 5, small, medium, large. Is that greater than the square root of 41? That is true, it's a triangle. So 3 squared is 9. 5 squared is going to be 25. And these are the small sides. How does that compare to the quantity square root of 41? So the square root of 41 squared is 41. And 9 plus 25 is 34. Since 41 is bigger than 34, this is an obtuse triangle as well. Last but not least, we have 2 root 5, 6, and 7. So 2 root 5, 6, and 7. 2 root 5 is approximately 4.47. So this would be small, medium, large. So 2 root 5 plus 6, is that bigger than 7? The answer is true, that's a triangle. So I'm going to do 7 squared. And then my sides that are small and medium, I have 2 root 5 quantity squared plus 6 squared. 7 squared is 49. 6 squared is 36. 2 root 5 squared is 2 squared times 5, which gives me 20, because 4 times 5 is 20. So I'm going to compare 49 compared to 20 plus 36, which is 56. 56 is bigger, so this is acute triangle. Now, all of these work, so when all these work, we got an issue. That means everything works. So, my question is, extra example here. Throw down here at the very bottom, you have square root of 5, 6, and 7. So same example, but no 2. Okay? What happens? Well, square root of 5 is approximately 2.23. Oh, shoot, that one still works too. We'll make that easy. We'll make this a 9. This is 2.2324, really. This is 6. So square root of 5 plus 6, is that bigger than 9? No, because this comes out to be approximately 8.24. Is that bigger than 9? No. So when it's not true, you just say not a triangle, and then you can't classify it except you say not a triangle. Okay? So if it doesn't work, this is why you have to test your sides first. If it doesn't work, you must then tell me it's not a triangle. If it works, like all the examples up above did, if it works, then cool. Do the math with it with the Pythagorean theorem to see which side, left side hypotenuse, or the sum of the legs, a squared, b squared, are bigger, but you got to test to see if it's a triangle first. Your homework is homework 48.